Hello, programmers! Today we're going to talk about big O notation. It's a way that we can compare algorithms and talk about the runtime in a more abstract way. Let's look at this little C program here and analyze this algorithm. It asks the user to enter in a number n, and then we'll go through a while loop and print all the values from 1 to n. So 5, we're going to go through the while loop 5 times. If I run it with 100, we're going to go through that while loop 100 times. If I run it with 100,000, we're going to spend a lot more time in that while loop. And the amount of time that we spend in the while loop is definitely dominating the runtime of this algorithm. So if you think about the number of lines that are executed, this setting x to 1, that is going to happen very fast, and it's going to only happen once. The printf, the scanf, those are only going to happen once. Return 0, that's only going to happen once. But if you look at the while loop, that's going to happen n number of times. So that while loop is dominating the runtime for this algorithm. Let's say I'm going shopping for the latest iPhone and an orange. I'm probably just going to tell people I'm going out shopping for an iPhone because the price of the iPhone plays a much, much bigger role in my overall bill compared to the price of the orange. It's the same way with time complexities. If your big O time complexity is 3n plus 2, we can just abbreviate that and say it's a big O of 3n. And in fact, we can simplify it even more and just say it's a big O of n time complexity. What if you have some nested for loops? You're going from I is 0 to I is less than n, and that is inside of another for loop that's going to go n times. We say this is quadratic time, or n squared. Let's imagine you go to the grocery store, and there are 3 different lines you can choose. Line A, where all you know is the worst case is you'll be in line for 20 minutes. Line B, the average customer is in line for 15 minutes. Line C, the quickest you'll get out is 5 minutes. Which line would you choose? There's no wrong answer here, but it kind of depends on how risk averse you are. If you want to take a chance, you might try line C, thinking you might be the person that gets out in 5 minutes, but what if somebody else stays in line for 5 hours or 5 years? Letting us know only the quickest case is not a very good guarantee for what is the worst that could go wrong with standing in this line. Line B is not too bad because if there was one person that was in line for 5 years, that would really skew the average and it wouldn't be a 15-minute wait time, so that's okay. But line A, being able to say you might get out faster, but 20 minutes is the worst that you're gonna do waiting in this line. That's kind of where we're going with this software analysis. Big O notation is an upper bound, saying the algorithm's going to perform at least as good as this, if not better. So yes, you could analyze algorithms and talk about the worst case, the average case, the best case, but usually people are most interested in knowing the worst case. If you pick this algorithm, what is the worst that could go wrong? And then that's kind of playing it safe when you're advertising the strength of your algorithm. Let's look at this little algorithm and see if we can figure out what the big O notation is. It really depends on what the user enters in as n. If they enter in something that's less than 50, like 5, we're going to have a big O time of 1. But we can't ignore the else statement. If they enter in something that is bigger than n, then we're going to go through a for loop n times. So the n is really going to determine the input of our program. We can't predict what the user is going to type in, but when we're talking about big O notation, we need to give them the worst case scenario. So the worst case scenario is they enter a really, really big number for n, and we're going to be stuck in this else doing the for loop. So as the n that they enter gets bigger, our program will run longer and longer. What about this problem? You might think, well, it's one for loop, so maybe it's big O of n, but let's look at what's happening to y. Instead of going up by 1 each time, we're multiplying y times 2. This is actually a log base 2n time complexity. If we multiply it by 3, then it's a log base 3 of n time complexity. By 10, it's a log base 10 time complexity. But when it comes to logs, all the logs are very similar in their curve and the rate of growth, so we can just abbreviate that to log n and leave off the base. Here I made a little graph with log base 2, 3, 4, 5, 6, 7, 8, and we can see that those are all in the same ballpark, which is a much slower rate of growth than big O of n. Here's a chart of some of the common time complexities and a description going from the best case scenario, you're looking for something that's big O of 1, to things that are getting worse and worse and worse. And that's big O notation in a nutshell. The execution times for your programs can be influenced by hardware differences, CPU speed, RAM speed, disk I/O, what else is going on with the system load. So instead of using a stopwatch, we're going to use something called big O notation. Happy programming!